Hello, I'm Dr. Keith Miller from Kansas State University, and this particular demonstration is to illustrate the impact of magma viscosity on the nature of volcanic eruptions. Now, viscosity, that is how thick a liquid is, or how much it resists flow, in magmas is a consequence of the amount of silica that is in composition of the magma. So the more silica-rich a magma is, the more viscous it is, or the thicker it is. The less silica it has, the thinner it is, or the less viscosity it has, and the more easily it flows. And this factor, the amount of viscosity of a magma, has important effects on the nature of volcanic eruptions and the nature of the volcanoes that are formed as a result. So what I'm going to illustrate is how the viscosity of the magma impacts the nature of the eruption. Now, what high viscosity does is that it prevents the gas that's within the magma from easily escaping. All magmas have gas, and those gases are dissolved in the magma, just like carbon dioxide is dissolved in a soft drink. And the higher the pressure is, the more carbon dioxide can be dissolved in that liquid. And so as the magma rises up towards the surface, that releases the pressure, and that causes the liquid to become supersaturated in carbon dioxide, and the carbon dioxide escapes. So all magmas will do that as they rise and lose pressure. But if they're very thick, if they're very viscous, what happens is the gases cannot easily escape that, and they get trapped, and effectively what happens is the magma foams as it rises up towards the surface and results in an explosive eruption. So in this demonstration I'm going to use coke as an illustration of the different viscosities of magma. We're going to start out with regular coke. And this will represent the low viscosity magmas. These are magmas that have low amounts of silica, be characteristic of volcanoes that have basaltic compositions like occur on Hawaii. And so shake it up just a little bit, and then we'll release it. And what you see is it foams, the gas easily escapes into the air, gets removed from the liquid, and the magma itself that's left has lost its gas, and if the pressure continues to move it up to the surface, it would flow out gradually onto the surface as a lava flow. By contrast, if the magma has a lot of silica in, that is, it's very viscous. So here again we have another coke, but this has been thickened with wallpaper paste. So I'll shake this up really good. And what this illustrates again now is a magma that has a lot of silica in it, so it's very viscous. That means that the gas that's trapped as pressure is released will have a hard time escaping, and we'll see what happens now. And as you see, the gas, rather than escaping out into the air, propels the liquid out of the container, out of the magma chamber. And notice that the magma continues to flow as a foam. And that's effectively what an eruption is like that has a very high viscosity. It erupts out effectively as a magma foam, and it's propelled by very high pressures, and that magma will continue to come out of the volcano, lowering the amount of magma in the chamber. And when this finally stops, this goes on can go out for a long time. It's going to propel most of the magma out of the chamber. Now, after a period of time, what would happen in actual volcano is after that gas escapes, that pressure is released, the remaining magma that will now have lost its gas will fall back down into the magma chamber, and you can have what's called a caldera collapse, which is the overlying part of the volcano collapse into the now empty magma chamber below, leaving a circular caldera at the surface. So to review, the viscosity of magmas are absolutely critical in the types of eruptions that are produced. Those that have a low viscosity, gases escape and they end up being relatively quiet eruptions like lava flows. Those that have a high silica content and a high viscosity will end up being those that are the explosive types of eruptions, what we call Plinian eruptions, the most explosive of the volcanic eruptions.